Okay, welcome back. We're going to continue on, and now we're going to move into some basic terminology here. So, as perhaps maybe you started thinking about in the last slide of the last video, is that this notion of type is extremely central to the C++ programming language. The terminology that we're going to use for the remainder of this lecture and then also throughout the remainder of the course, in fact, might differ from that of other programming languages that you're already familiar with. So in C++, we're going to define a type as something that essentially defines a set of possible values and a set of operations for an object. So the next question then is, well, how are we going to define an object? We're going to view the object as our abstraction of a computer memory cell. It's going to hold a value of some given type. The value, now going kind of through the process, well, what's that? It's going to be the set of bytes in memory that are interpreted according to the specified type. And we're going to say that a variable is simply a named object. Moreover, we'll start talking about how we can introduce variables into our programs. We'll start, I guess, we'll not necessarily start, but towards the end of the lecture, we'll get into a declaration, and we'll simply, define that here as a statement in the C++ language that gives a name to an object. And for all the primitive types that we're going to introduce today, a declaration will also include the definition of that object, and we're going to simply define a definition as a declaration that sets aside memory for an object. Now, how you can kind of think about this, it's rather informally, is that we can think about an object as a box that we can place values of a given type in. So kind of looking at this here, we have this box named A, so that's going to be an object named A. We also have one named B. They both can store integer values, so we can put in any sort of integer value that would fit within it into that box. If you notice here that each box of the type int is the same size, although it can store a different value. Moreover, if we look at, say, different types of objects like a character, if you look at C here, its size is going to be noticeably smaller than that of an integer. And these aren't kind of drawn to scale because in integers, size is actually left up to the implementation of the language that you're using. So it could be a fourth of the size of a character, a character could be a fourth of the size of an int. It might be an eighth of the size of an int, etc. But the key here is, they're different. Then we can get into floating point values. It's going to be a box that allows us to store some value with a decimal point. We can see here that, this box will likely have a size which could be different, could be similar as an int. More likely than not, it's definitely going to be larger than a character, which is pretty much always guaranteed to be a single byte in C++.